In this question, we are asked to find a dot product between a couple of linear combinations of x and y, given a whole bunch of information provided about x and y. So what's really nice is that we can use some of the properties of dot products to expand and simplify this. So what we're going to start with is using that second property of dot products, which basically says that if I have u plus v dotted with w, I can split that up into u dotted with w plus v dotted with w. It's basically like distribution. So I'm going to be able to do that actually on this here as my u, and my v will be the negative 2y, and just sort of distribute the thing on the right kind of back to those two terms, just like the format over here. So what we're going to get is x dotted with 3x plus 5y, and then minus 2y dotted with the same thing. And while it's not a property directly in the list, if you actually combine properties 1 and 2, which property 1 is the commutative property, so we're allowed to flip things around, it allows us to do kind of the same thing in reverse. So this is just kind of a mishmash of those two properties. So I need my dot product in there. So that'll be u dotted with v plus u dotted with w. So what I can do now is actually sort of do the distribution going the other way. And I'm going to get kind of a combination of 4. It's actually just like FOIL, really, if you think about it. So I'm going to get x dotted with 3x plus x dotted with 5y minus 2y dotted with 3x, and then minus 2y dotted with 5y. And property 3 is now going to allow us to deal with all those scalars. So property 3 is that if I have cu dotted with v, it's the same thing as c u dotted with v, or u dotted with cv. But basically it means any scalars we're allowed to just sort of pull out to the front. So this is 3 x dotted with itself plus 5 x dotted with y minus 6 y dotted with x minus 10 y dotted with itself. And then we're going to just use a couple other properties here. So we have that commutative property. So this is equal to x dotted with y, right? And that's just property 1. And then what we've also got is our formulas for length. So just recall that the length of x is actually just x is the square root of x dotted with x. And the length of y is the square root of y dotted with y. And so what those mean is that x dotted with x is actually the length squared. And then similar for the y's. So it's actually just going to be those values squared. So I'm going to be able to just write this as 3 times the length squared. And that's going to be, those two things are the same because of the commutativity. So I can just add the 5 and the negative 6 to get minus 5x dotted with y. And then minus 10 of the length of y squared. And I've got all those values. So now I just plug things in. I get 3 times 3 squared minus x dotted with y is negative 2. And minus 10 times 1 squared. So I get 27 plus 2 minus 10 is 19. And that's our answer.